Okay, we're going to look at the final review for second semester Algebra 2, and I've created some model problems to help you when you're doing your own review. And on the first one, we're supposed to classify the function here as either linear or quadratic, and then we're supposed to identify the parts of it as either quadratic, linear, or constant terms. You'll need to distribute to start with, so 4x times 2x. 4x times negative 9. And you'll distribute down here 2. And then the minus times the negative 7, as that double negative turns out to be 7. So let's collect our like terms, and in this case the quadratic term disappears. So we end up with minus 36x plus 7. If the x squared part had not disappeared, then this would be quadratic. But since we have a highest exponent of 1, you might see that I put a little 1 there. Let me make it a little more obvious there. This is linear. And there are only two terms. There's the linear term. So let me write quadratic none. That's the one that canceled off. The linear term is that negative 36x, and then the constant is the 7. You don't need to put the plus sign, it's positive. Okay, on this next one here, we're supposed to find the value of c that would give us the x value of 3 and the y value of negative 9. Hopefully when you see a point like that, you think, oh, they're giving me the x and they're giving me the y. So we'll plug in place of that y there. This is a y value. We're going to put negative 9. And then everywhere you see an x, you're going to put a 3. Okay, so now it's just a matter of simplifying this and solving for c. So we have negative 9 here. The 3 squared is 9, and then minus 12 plus c. And we'll subtract 9 and add 12. From the other side. And that tells us c is equal to negative 6. Okay, problems 3 and 4 here. On problem 3, we're supposed to find the y-intercept. And a brief explanation here. If you're looking for a point that's on the y-axis, then you know you're looking for a point where the x part is equal to 0. So all we have to do here is very simple. When you're looking for the y-intercept, you set the x as equal to 0. And in doing so, this whole first part cancels off, since 0 times 0 times 8 is just 0. Likewise, 5 times 0 is just 0. And adding 9, you can find out that this function will cross the y-axis at 9. Okay, a parabola has its vertex at 2, negative 5. What is the equation of the axis of symmetry? Very simple. We don't really know which direction this parabola is pointing. I'll just assume that it's pointing up. Its vertex is at 2, negative 5, which is 2 to the right and 5 down. And the axis of symmetry is always a vertical line through that point. So it's as simple as saying x equals 2. That's what vertical lines look like. You've got a x equals 2. Well, and x equals is what you put when they're vertical lines. Y equals is when it's horizontal. Okay, examples 5 and 6 here. We're supposed to graph this function. So I'm going to go to the y1 line, y equals on my calculator, and just type in that function, negative x squared plus 6 and then I'm going to go to the table of values. First of all, you go to the table settings and put it in automatic mode, and then you go to your table and just poke around on the table there and you'll find out that there's symmetry on either side of 0, 6. So 1, 2, and 3, negative 1, negative 2, and negative 3. And the numbers go 5, 2, and negative 3 on either side. And this is your vertex at 0, 6. So I'll come on up here and put 0, 6. And then it drops to 5 on either side. And then down to 2 on either side. And then down to negative 3. And draw your parabola. Now you might also try doing this a little differently. Put this on the y1 line and then hit zoom 6 and trace to find the points. So for instance, trace 0 should show this vertex here. And if you say trace 1, you'll get 1, 5. And trace 2, you'll get 2, 2, and so forth. Okay, on this next one here, we can find the vertex easily. This is the opposite of the h value, so I'm going to put a 1. And then the k value shows up just right there. 110 is our vertex. So I'm going to make a table of values. And let me do that a little bit better. With 110 as being my vertex. And if you go on either side of 1, you get 2, 3, and 4. 0, 1, negative 1, and negative 2. So those are the values we're going to put in. And in the meantime, I'm going to type the function on the y1 line. So on my calculator, I'm typing 0.5 and then a parentheses, x minus 1, close parenthesis, and then I'm hitting the squared key. And then finally plus 10 on the end there. And if you trace it, hit zoom 6 here and trace it. Let's see what that looks like here. Sorry, I'm having some issues. I'm going to go to the table of values. Okay, at 1, we have 110, and on either side it goes up to 10.5, 10.5. It looks like most of this is going to be off the graph I chose, so this problem was poorly chosen. But anyway, you get 110, and then it goes up to 10.5 right here. And then this little parabola is going to be shooting up like that. And you're going to have to expand the window above Ymax of 10 in order to see it. But the numbers should be 12 here. And then symmetry, we're going to have 14.5 on the bottom and 14.5 on the top. So once you get that table of values, just plot them. And I think I was more careful when I made your problem. It'll fit on the graph. Okay, write the vertex form of the equation that goes through 4, 13 and has a vertex of negative 4, negative 3. Well, vertex forms looks like this. Y equals a x minus h squared plus k. And we're going to use this x and y, and since this is the vertex, it'll be h and k down here. So h is negative 4 and k is negative 3. All right, the first thing I'm going to have you do here is plug in the x and y. And then it's minus h, which you interpret as being the opposite of h. So the opposite of negative 4 is positive 4. And then you put your squared, and then your k just follows. So I use this for h and this for k, but the formula itself says the opposite of h. So you have to change the sign when you plug that one in. So let's add 3 to both sides. And while I'm at it, I'm going to take 4 plus 4 is 8. So then we get 16 equals a times 64. Dividing both sides by 64 gives 1/4 for a. And now we find the equation by plugging in the new information, the a and the h and the k. And that's made a little bit easier if you look at this line right here, and you leave out the 13 and the 4, but you include the a value that you found. So just plug it into the original formula. You have to plug in the a, the h, and the k, or the a, the opposite of h, and the k. All right, number 8 will be the last one I do on this initial video. And we're going to start by using FOIL on the back half. So for now, that negative 2x is just going to hang tight. Okay, 5x times x. And then the outside pair is 5x times negative 8. The inside pair is negative 2 times x. And the last times last is negative 2 times negative 8. Yeah, I'll consolidate a little bit on the inside here. And now we multiply all the way down, multiply by negative 2x. So negative 2x, when you distribute it on the first term, gives negative 10x cubed. And then we have a negative times negative on the second half here. I've already done that first half. So that's going to be plus 84x squared. And finally, we multiply down here and you get negative 32x. Okay, we've written it in standard form. And that'll be problems 1 through 8 on the review, and I'll have subsequent videos.